Okay, hello everyone. I am Om Godge and today we'll be discussing Lab 11. So the first question was Nim Game, in which you had n heaps of stones and you wanted to find which player would win if you can select any number of stones from this. So there is a whole proof for this, but you don't need to understand what the proof is. So if you go to this Wikipedia article, you will see somewhere here that they have said they have told you to take the XOR of all the numbers and see if the XOR value comes out to be greater than 0 or not. And yeah, that's what you have to follow through. Though getting into this proof for this will not be is not what we wanted. You just need to know that you can take the XOR of all the numbers and get your answer, and it's called a Nim sum. So when you take the XOR sum, when you take the XOR sum of these numbers, it is called the Nim sum. Yeah, so that's all you need to know. Yeah, here is the proof. So the proof would require you to understand some amount of game theory, so I'm gonna skip over the proof, but that's all you have to do. If XOR sum is greater than 0, then the first player can win, otherwise the second player will win. Yeah, that's all for this question. Okay, so the next question that you had was about hash maps. So I'll just explain what a hash map is. So a hash map is basically a vector of linked lists. So each of these is a pointer to a linked list. So you'll have a linked list over here. Yeah, my drawing is bad, but I hope you get the point. Like there's one linked list here, there's one linked list over here, and so on. What do these linked lists store? These linked lists store the airports, the cities and the airports that you have. So think of it this way, that you have like these buckets. Yeah, these buckets, they are not nice, but yeah, you have 5 6 buckets right now, and you can place, um, you can basically segregate all the cities that you have into these 6 buckets and store them separately, depending on, let's say, like there can be multiple factors. Let's say you have, like, this is the world map, and you divide the map into 6 parts. So you divide it this way: 1 2 3, and then you see, like, whatever city lies in this particular region will belong to this bucket, and whatever lies in this region belongs to this bucket, whatever lies in this region belongs to this bucket, and so on. So that is how you segregate all the cities, and then this allows you to search for things faster. So let's say you want to search for Mumbai. So instead of searching through all of the cities, you can only search that particular region, the cities that are stored for that particular region, and you will only access that linked list and check all the elements stored there. That is why hash maps are used. Also, hash maps allow you to sort of give you use a key. So you can use this city name over here, Mumbai. I'll just write mum for now. Use a string to get the corresponding node or the information, let's say info, with you can use the key, which can be any data type, to access its information, whereas with arrays you always need a number or an index to access about that particular city, let's say. Okay, I hope this makes sense. That's why hash maps are used. Yeah, so this is the structure of a hash map. Now, there was some boilerplate code given to you, and there were 2 questions. Like, one of them was for you to implement insert, and the other was to implement remove. So I'll explain both of them one by one. So actually, most of the code is very similar to what you have done in your previous lab. So you had solved inserting and deleting elements in the linked list in your previous lab, right? So just go through that once. I'll just explain the differences or the new things that are there in this question. So the first thing you have is a hash map, which is a vector of linked list nodes. It is of size groups. Groups is a number that is predefined in hashmap.h, which is set to 10 for now, and all of them are set to null pointers for the start. Then isEmpty is a simple function which tells whether the hash map is empty or not. So counts the stored in the map, and if it is 0, you return true, else return false. Yeah, so you go and check every single pointer in this table, and you see if this pointer is not null, then you keep on doing cur equals cur dot next. So over here, let's say you have this table, you have two pointers 1 and 2, and you have some elements here. So that's 1, that's 2, that's 3, this 1 more, and then there are pointers here. This is pointing to null, and then this is also pointing to null. Okay. So the first thing that you do is you iterate over all the pointers in table. So first you will go here, then you will go here. Like you are iterating over these pointers one by one. So the first pointer that you select is this one, then the second pointer you select is this one. Then while this pointer is not null, so this is not null, you will keep on going to the next pointer and going to the next pointer and going to the next pointer. Over here, core becomes null, so it will stop. And then inside the loop, you do sum plus plus. So when you reach here, you will do sum equals 1. When you go here, sum equals 2. When you go here, sum equals 3. And here you will not add anything because cur is null over here. Then you go here and then you do sum equals 4, and then again cur is null. So then your sum will become 4 and it is not equal to 0, so this function will return false. It will return true when there is nothing in the hash map, when these elements are not there. In this case, your sum will be 0 and the function will return true. Okay. Then you have a hash function. So what this hash function does is, I'll just write it in the code directly. Takes string and assigns index in the table. So you have this table. Let's say you want to insert Mumbai in this. So Mumbai is the key and the value for Mumbai that you want to store is 4. So to find the index corresponding to Mumbai, the hash function is used and it gives a number from 0 to groups minus 1 to Mumbai, sort of randomly. So it gives Mumbai a number from 0 to groups minus 1. In our case it will be from 0 to 9, and it is sort of random, but in the code here what we do is we simply add up the ASCII values of all the characters in Mumbai. So you'll add up the ASCII values of M, U, M, B, A, I, and then simply take the remainder with the number of groups. So when you take the remainder with the number of groups, you will get a number between 0 and groups minus 1, and then using that number you will index into the table array. Okay. Now you have the insert function. So when you're inserting element, the first step when inserting a key value pair, the first thing you do is find the index at which you have to enter insert the node at. So you use the hash function to figure out which index to insert at. So if you want to insert Mumbai comma 3, you will call the hash with Mumbai and then get the index at which you have to insert Mumbai, and then you will get the pointer corresponding to that particular index from the table. So let's say you get 1, so this is the place where you have to insert Mumbai. So then you will create another pointer and you will call this cur, which is pointing to wherever this particular pointer is pointing to. And then this kind of follows insertion in a linked list. So you can go and watch the previous video once to understand what is going on here, how to insert in a linked list. And this is a special case. So this is the case where the key already exists in the hash map. Okay, so once you have gotten this particular pointer here, then what you have is simply a linked list. Like this is just a linked list from here on, and now your job is simply to insert a new node in this linked list at the end. Like you have to insert a new node at the end. So you just keep on moving this arrow below and reaching. So core will keep on moving down. I have not drawn these arrows, so these arrows are implicit. Like there's an arrow from here to here, here to here, here to here, and here to here. Okay, and okay, so you keep on moving ahead until you reach a place where the next pointer is null, and then here what you do is you create a new node at the next position, and you enter the details of that particular city, and then you do not need this pointer anymore, so you can get rid of it. So this is how the insertion takes place at the end. This is the case where there is no element from the start, so there is nothing stored in the linked list, everything is empty. In that case you will have to create a new node at this position. So that's why I've done table hash value equals new linked list node. Otherwise you can always do cur next equals new linked list node. Okay, and then this is the case where the key already exists, so you've already added Mumbai into your hash table, and then you will just update the previous value in the linked list. Okay, you just update the previous value that was stored and set it to the new value that you read. Okay, and then this is the same as, so in this code what you do is you keep on going ahead until you get to the place where you want to insert. So yeah, over here so in this code what you do is you keep on moving the cur pointer, so you keep on moving this ahead, like this starts from here and then you move it ahead. If you encounter that a particular node has the name same as the key, then you have to update the value. If you don't come across such a node, then you will keep on going up to the end where core.next will become null, and then you reach here, and then you will create a new node from here at core.next, so core arrow next, sorry, At core arrow next, you create a new node, and now you have a new node in your linked list. You put the name, key, and a value, and you set the next, this guy's next pointer to null. Like this is pointing to nothing. Yeah, similar to this. Now for remove, the remove is rather simple. So you just find the hash value, and you access that particular linked list, and then you keep, if the first node is the node that you want to delete, so if this node is the one that you have to delete, then what you have to do is you have to move this pointer to point here. So what you do is you just say table hash value equals cur next. So this was cur next is this, and then table hash value is this pointer. So now you're pointing it to here. Alongside this, you should also do this, that you delete cur. So what you should do is you should delete this particular memory. So yeah, this will do that exactly. Otherwise, if it's not the first element, then you will keep on moving cur ahead until you find the node that has to be deleted. So you'll keep on moving this ahead until you find that cur next is the one to be deleted. So let's say you reach here and you find that this is the node that you want to delete, like this one. So what you'll have to do is you'll have to move this pointer and point it here. So this is the one that you have to delete, so you'll move this pointer to here. Now you've gotten rid of this, and then you'll have to delete this node. So for that, what you do is while cur next. So while cur next is not null, if cur next name equals key, then you found the node to be deleted. Then you do cur next equals cur next. And before this, what you will do is linked list node star equals cur next, and then you do delete cur next, delete del. So you have deleted this particular memory location, and then you have changed this pointer to point here. That is the delete, the remove operation, or the print table is not really required, it was given to you. So yeah, this was the hash map question. The question that you have is restaurant order. So in this, you had to first understand what a queue is. So a queue is basically anything that has multiple things in it. If you want to add something new, you add it at the back, and if you want to delete something, you delete it from the front. So this will get deleted. Then you add something new, you'll add it here. You want to delete something, you delete from here. This is what a queue is. Similar to how you have queues in real life, like people get added at the back of the queue and people get removed from the front of the queue. This is how the queue works. So that is what a queue is. So the first in, the person that was in at the first, he goes out the first. That's called first in, first out. Yeah, that's all. So restaurant.h is already given to you. So restaurant.h is this. You have an order list, and it stores a vector of orders, and the order stores a customer ID, a customer name, and a vector of order details. So all the orders that have been made by this particular customer. So, and you have to implement 3 member functions for this: get order, delete order, and update order. So let's have a look at them one by one. So get order is easy. What you have to do is accept customer ID, customer name, and number of items. So customer ID CID, C name is customer name, number of items is N. So you just do CN, CID, C name, and N. You can write all in one line as well. And then you create a new order, and you store the customer ID and customer name in this order. Okay, once you've done that, then what you have to do is accept n item names and finally add them to the struct. So to accept n item names, I am assuming that there can be spaces in that item name as well. So I have done get line over here, and cn.ignore is done to ignore the first backslash, the first new line that you have. So it will ignore that and read all the inputs in one by one and push them into the order. So in this order, the order details, you will push all the orders into the order details, and then at the end you will push the whole order into order list. Okay, that was the get order function. Now delete order function is pretty simple. You want to delete the element that is at the start of this particular vector. So to do that, you will do order list.erase order list.begin. So begin is an iterator. It will give you sort of a pointer to the first element of the node, and you tell it to erase that particular pointer. So this will delete the first element of the vector. And then update order is simple. You just take in customer ID and a particular order, and then you iterate over all the orders in order list. This means that you are passing, like, you're iterating all the orders by reference. So whatever change you make to this order, it will also change in the order list, which is what you want. If you don't put this and, you will see like the changes that you will make here will not appear in your order list because it creates a copy. It will create a copy of that orders. So that's why you use this and over here to iterate through order list using references of those orders. And then if you find one order in which the customer ID is matching with CID, the one that you read right now, then you modify that particular order's order details and push back the new order that you had. Yeah, that was it for this question. What you have is book my ticket. So in this you have to book tickets for an IPL match. So you are given you are given ticket.h and main.cpp, and why is it? Okay, you are given ticket.h and main.cpp. Main.cpp is very simple, you don't need to understand it. Ticket.h, you have a ticket booking struct and an IPL struct. The IPL struct has a vector of ticket bookings, and you have to implement these three functions. This is very similar to the restaurant question. So the first function that you have is book ticket. It will just take in this is given here. You accept the ID, name, and number of matches. So ID, name are strings, number of matches are an integer. You take all of them as input. You create a new ticket booking object, not an object. It's just you just create a new ticket booking variable, and you store fan ID and fan name in it. Then you do see and ignore to ignore new lines, and then you read in the matches one by one, and you store them into this ticket booking object. Then finally you put this object into the ticket queue, similar to the restaurant question. Then in process booking, you just need to remove the element from the start because it's a queue. So you remove the first element that was inserted, and then in update booking, you take in the ID and a match, and then you find the one where the ID matches, and you update that particular match details, the match details corresponding to that ticket. Yeah, that was it for this question. Last question, flight connections. So in this you are given a graph.h header file, and you are given a vector of vector which contains a matrix which is called the adjacency matrix. So what this matrix stores essentially is you have this 1, 2, 3, and let's put this here. One, 2, and 3. So it just stores whether there is an edge from adjacency ij is true if there is an edge from city I plus 1 to j plus 1, and vice versa. Okay, that's what this stores. Okay, so this will be true if city 1 will always be connected, right? So these all will be true forever. The diagonal will remain true. You can always get from the same city to the same city. These are the interesting ones. So if this is true, I mean, these don't matter, like these you can forget this whole thing. These don't matter to you. You only this part and this part I mean, only the upper half matters, because the lower half will be the same as the upper half. If you can reach from 1 to 2, then you can always reach from 2 to 1 as well. That's why these will be the same. So that was the first part. To insert an edge from A to B, you will just do adjacency matrix A minus 1 B minus 1 set to true, and B minus 1 A minus 1 set to true. That was the first function that you had to implement. And the second function was is reachable. So in this you have to recursively check whether you can reach from A to B or not. So if this is the base case, if A is equal to B, then you simply return true. Otherwise what you do is you iterate over all the so what you're essentially doing is, this is the row for A minus 1. So you iterate over all the elements in this row and you check wherever there is true. So you check wherever there is true and this particular node is not visited, and you can reach B from this node. If you can reach B from this node, then you will set this to true. You will return true from here. If all of these like return false, or you cannot reach B from all the nodes that are reachable by A, then you will return false from here. So so yeah, that was it for this question. Yeah, that's all for lab 11.